All right, this is 8-1 in Advanced Algebra 2. We skipped over Chapter 7. This Chapter 8 is going to be short and sweet, 3 lessons, where we'll get a test in before spring break, which is only 2 weeks away, so it's real short and sweet, okay? Then today we're simplifying some rational expressions. First thing to recognize, on number 1, what kind of polynomial is upstairs? Monomial, binomial, trinomial, what do we got up there? Monomial, and what's this? Monomial. It can be simplified though, so let's just keep on simplifying. The numerator, nothing happens to it, but you see in the denominator, we got to take all that stuff to the 4th power, correct? And now with our note card knowledge, I'll bet you we know what 2 to the 4th power is without having to punch that in. What do we got? 16, a to the 4th, b to the 4th. Please stop me if you have some questions. I'm just going to skip over stuff I feel you should already know how to do, like power to a power and product of powers, but if you don't see it, holler at me. Sound cool? Now, isn't it monomial over monomial, correct? Coefficients, we just try to reduce them. 24 over 16, please reduce. So I'll start with my fraction bar. 8 went into each one of those, 3 halves. Is that what we get? Then with variables, are there any negative exponents? Yes or no? Nope. So where are there more a's? Up, 1 more. Where are there more b's? And 2 more, right? Basically, the back page of your homework that was due today from 8-0. Right? There's our answer. Pretty simple. Next guy. Ah! This is where we get crazy. It's going to be factor and cancel, factor and cancel, factor and cancel. First thing we need to realize is we do have variables in the denominator, but you see how this is an expression. We don't need to restrict our domain or anything like that because it's not a function. We're not graphing this. This is just an expression. Cool? And we will always assume that the denominator cannot turn out to be 0. Top guy, do you see how we have this trinomial right here? Correct? It is a quadratic. I would like to see if that can factor. So let's go through the old factoring cheat sheet for a second. Aren't there 3 terms on that puppy? Right? Is it a perfect square trinomial? Is that guy in the parentheses a perfect square trinomial? Is the first guy a perfect square? Yes. Is the last guy a perfect square? Nope. So it's not a perfect square trinomial. Next question is the a value 1? Yes or no? Yep. So let's find 2 numbers that multiply together to be 3 and add together to be 4. Find me those 2 numbers. Just kind of sketch them out right up here for me. And those, of course, are 1 and 3, right? Because if this is a positive number and that's a positive number, then both of these will be positive also. So doesn't this really factor into the 5x is still there? Isn't this really x plus 1 times x plus 3? Don't forget, when the a value is 1, this is easily factorable. You don't need to do that frowny face thing, right? It's just, it will turn out to be the x with this number and the x with that number. Y'all cool with that? This guy, can that simplify it all? Just that quantity of x minus 6. Nope. So I'll make him blue, x minus 6. This guy, can anything happen to him? Isn't that got 2 terms? See, it's quadratic, right? And it's got 2 terms in it. Is it a difference of squares? So factor it for me. Since that's a difference of squares, hopefully, which there was a ton of difference of squares on that homework due today, we can factor it correctly. Does it factor into A, x minus 3 quantity squared, or B, x minus 3 times x plus 3? What does it factor into? Choice B, right? It's not a perfect square trinomial thing. It's x minus 3 times x plus 3. Everyone with me so far? All I did was factor the quadratics down to linear situations. I got fraction on top of itself. I want to see if I can cancel anything out. Do I have anything exactly the same upstairs as I do downstairs? So goodbye, goodbye, right? Anything else that I got? So here's our answer. It's 5x times x plus 1 over x minus 6 times x minus 3. You can if you want to, but then you'll get a quadratic. You want everything as factored as possible into linear situations, okay? And if you did distribute, the question was, why don't we distribute this 5x right away? Because the whole concept is we're trying to take things out. And if you did distribute that through, then you'd have a GCF of 5x and everything that you'd have to pull out right away. You with me on that? So we're always thinking, can I get it as linear as possible on this situation? So there's our answer. Good question. Next one. You see how they're all monomials, right? Let me go back to this one. This was a monomial, but wasn't this a trinomial, a binomial in this situation? The next one, aren't they all monomials? And if you take a monomial times a monomial, you'll get back a monomial. One guy times one more guy will be one guy. Isn't 1 times 1, 1? So let's do this. Let's multiply the numerator together. 60 r squared n cubed t squared. There's no particular order to put those in except for the coefficient. Should come first. Over bottom, we'd get 9 times 5. Help me. 45. T to the 4th, r to the 3rd, n to the 1st. Sweet. Coefficients now, see it's monomial over monomial still, right? Monomial over monomial, that's the easy one. Just reduce coefficients, then where are there more with the variables? What's the biggest number that goes into 45 and 60 evenly? 15. So that'd be 4/3. R's, there's one more down. I cross stuff out also. N's, there's 2 more up. And T's, there's 2 more down. Pretty good with that? Monomials all over the place. And what were we doing with them? We were multiplying them together. Next guy. You see how it's all monomials again, right? But what's the operation we're doing with them? Dividing them. So we can't divide fractions. Instead, we will keep the first guy the same. So nothing happened to him. But we will now, instead of dividing by this guy, we will multiply by the reciprocal of that guy. So don't we just need to flip him over? Right? Dividing by a fraction is the same thing as multiplying by the reciprocal. And I'll let you get that done. Then we can obviously do all our reducing. That'd be 4 over 1. M's downstairs, there's 4 more. C's, there's more down here. K's, there's only K's upstairs. And D's upstairs. Did I do that right? C's, where's, oh, I didn't have the C squared when I rewrote it. Thank you. So the C's cancel. My bad. C squared over C squared. I missed my 2 there. All good? Monomials all over the place. No need to factor. Cool? Monomials. Next one. You see how there's not monomials involved. So this is a trinomial, this is a binomial, this is a trinomial, this is a trinomial. Time to factor. So one at a time. This guy. Also notice it's a multiplication problem. I don't need to like switch it and do a reciprocal or anything like that. So factor this for me together. Why don't you pause the video and factor that green box for me. Talk yourself through that cheat sheet. I'll even display it for you. So, is it a perfect square trinomial? First guy is a perfect square. The last guy is not a perfect square. I can, even though 16 is a perfect square, this isn't a 16. That's a negative 16. You with me? So I can tell that's not a perfect square trinomial. 2 numbers that multiply together to be negative 16 and add together to be negative 6 are 2 and 8. And which one needs to be negative? The 8. So this is really x plus 2 times x minus 8. That's right here. Correct? Now, let's factor this guy. 3 terms again. Talk yourself through the steps. First, is it a perfect square trinomial? So, let's see. First guy's a perfect square and last guy's a perfect square, but that's not good enough. We need to figure out what their square roots are. This would be an x. This would be an 8, right? And then bring the sign down in the middle. and realize, is this guy twice the product of those square roots right there? If you multiplied these together, you'd get negative 8x. Is this twice as much? Yes or no? So that's really x minus 8 quantity squared. But I'm not going to write x minus 8 quantity squared. This is the time where you want to write just the two things exactly the same. I mean, you can write x minus 8 quantity squared. It's easier if you just split them up into the x minus 8 times x minus 8. You see how that's the same thing as this? You with me on that? Times itself. Cool. So I'm gone with you. Numerator up here, I'm just going to put times. It's an x minus 8. You see how I can't factor it? There's no GCF, and it's linear, right? How do you know it's linear? X is raised to the first power. So you do check for GCFs, which there is none. Cool. This guy right here, maybe he can factor. I'll let you give him a shot. Be careful with it, right? A lot of people put x plus 1 and x plus 6. That's not what it factors to, because even though those numbers multiply together to be 6, they add together to be 7, right? I want them to multiply together to be 6 and add together to be 5. So what do I got? X plus 2 times x plus. And let's see if I can do something for you. It's a good idea that what these factor to, I'll bet you that there's some of these quantities somewhere else. Did you see how there was an x plus 2, like upstairs also? It's a little hint. The idea is we're supposed to factor and cancel, factor and cancel, factor and cancel. Pretty decent idea that if there's an x plus 2 upstairs, there's a good chance that there's going to be an x plus 2 downstairs also. So now, you're going to multiply it all together. Let's just start canceling. X plus 2 up, x plus 2 down. Don't they cancel? You with me? X minus 8 up, x minus 8 down. Those cancel, correct? X minus 8 up, x minus 8 down. Those cancel, correct? There's still some leftovers. Where are they at? Upstairs or downstairs? So they got to stay down there. You're left with x plus 3. What the heck's left upstairs? The 1. Remember, we're not going to say x can't equal negative 3. We're not trying to restrict the domain because this is not a function. It's just an expression, and we're just realizing that this is what it would simplify to, and we understand that the denominator cannot turn out to be 0. Okay? Next one. Pa-pa. Woo! Look at this. Bye, bye, try, try. It's a little twist on the old Backstreet Boys. It's bye, bye, try, try. Right? Multiplication or division problem first. Division. So, will anything happen to this guy? Will he need to get reciprocated? Does that guy need to get reciprocated? The first guy. Nope. Can he factor, though? Like, I don't want to write all these crazy steps down and then have to rewrite this and rewrite that and all this writing. Let's factor this guy right away. This guy. 2 terms. Is it quadratic? Yep. So, first thing to check for, 2 terms, is it a difference of squares? What do you think? Oh, yeah. That is a difference of squares. So, I went the wrong way. This guy will factor to x plus 4 times x minus 4. Right? What are those called? X plus 4 and x minus 4. Starts with a C. Those are conjugates of each other. The bottom guy, he is a binomial, but do you see how he is linear? You with me? There's not any squareds in there. So the only thing you could do to that, if you wanted to factor it, is maybe take out a GCF. Can you find a GCF that can come out of there? 12. So you got 12 times y plus 3. Right? The second guy, we're going to change it to a multiplication problem. So do you see how I have to do some reciprocating? Correct? You with me on that? So I'm going to look at this guy right here, which is really my new numerator. But can he factor? Since that's got 3 terms and it's a quadratic, can I factor that green box of information? Probably. If you're not sure, the answer is probably factor it. So I'll let you do that. Find 2 numbers. Since the a value is 1, pretty easily factorable. Maybe it's a perfect square trinomial. Maybe it's not. What 2 numbers? 3 and negative 6. We're okay with those? And it's cool if you want to jot them off to the side or whatever. So that'd be x plus 3 times x minus 6. Sorry, it's y's, right? Woo, I would have really screwed myself up there. What's the big variable in this guy? Y's. That would have really been bad because you see I couldn't have canceled those. But now that I caught myself, because I'm an idiot, that we get y plus 3 times y minus 6. Very suspicious that there was a y plus 3 downstairs, and it turned out to be there's a y plus 3 upstairs also. Interesting. How about this guy? He's coming down. Wonder if he can factor. Take a guess what may or may not be involved with this one when you bring him down. There could be some 4s or negative 4s involved with that situation. What you got? What two numbers? Negative 4 and negative 8. They're both negative. They multiply together to be a positive, right? And they add together to be a negative. That's good. So that's x minus 4 over x minus 8. Now, can anything else cancel at all? You see, linear, no GCF, 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 linear, no GCF. You see how it's as reduced as humanly possible. It's time to cancel. So, goodbye, bye, bye, bye. Right? All the leftovers, they stay. You got x plus 4 as a quantity. Make sure you have them in parentheses. Y minus 6 as a quantity over 12 times x minus 8. And nothing can reduce. People are like, well, what about the x plus 4 and the x minus 8? Could you do something with those? No, you cannot do anything with those. Cool? When it's more than one term, they have to be the exact same quantity on top of each other for them to cancel. Goody? Yeah. How'd you feel about that? Seem pretty simple, minus the fact that it's just factoring, right? It's all factoring. Now we'll throw a twist on it, okay? Sometimes we'll have to do a little manipulating and factor out a negative 1 out of one of these quantities. So let's just see what happens. Top guy. All linear, correct? More than one term, GCF. Can you take a GCF out? We can take a Z out. And what would be left would be x minus 4. Is everyone cool with that? Yes? No? Maybe? This z squared, if you really, really wanted to rewrite him, it's z times z, or you could leave him z squared. It doesn't matter, but you see how it's just a monomial right here, right? That is a monomial. So you could actually leave him as z squared or think of him as z times z. I don't care what you put. And this guy right here, that's a binomial, but he is linear, correct? Is there any GCFs that can come out of that? So it would be like this, 4 minus x. Good with that? Now, look at these two. Close, but no cigar. Tell me about the x in this guy, positive or negative? And this one is negative. Tell me about the 4 up here, positive or negative? And this one is, are they like the same thing except for the sign? Those are not conjugates of each other, though, because conjugates have the same first guy and a different second guy. Right? You see how the first two are the same sign, the last two are different signs. Right? So not conjugates, but what we could do is if we factored out a negative 1 out of either one of these, just one of them, it doesn't matter which one, what would happen if you factor out a negative 1? What would this positive x turn into? A negative x, what would this minus 4 turn into? So what we're going to do is realize that these are going to cancel each other out, but you have factored out a negative 1, so there's still a negative 1 that came out of that. Let me write it all the way out. It's like you did this. There's the z from upstairs times the negative 1 that you just factored out, and wouldn't you have negative x plus 4 left over? You all see how I did that right there? Now look at these two. Aren't they the exact same thing? If you use the commutative property of addition, isn't that really 4 minus x right there, correct? Those cancel. But you see how there's a negative 1 that remained in that situation. Because they were almost the same thing, we had to factor out a negative 1. So here's what we got. We got negative z over z squared. Is that as good as it can get? Or can that simplify? Aren't there more z's downstairs than there are upstairs? With me? So what's it really simplified to? Negative 1 over z. Yow! 8. Give it a shot with pal. Just factor it. Factor the numerator is what I want you to do. Factor the numerator. What can we do to the numerator? Since it is a quadratic, but it's got all this other stuff in there. It's a binomial. What can we do to him? GCF, right? We want to GCF him. There's an A in each guy, and there's a B in each guy at least, correct? Can't we pull out an AB? What will be left in the first guy is what? B minus 5. Your denominator, nothing can happen to him because he's linear and there's no GCFs, so 5 plus B. And nothing can happen to him because he's linear and there's no GCFs, 5 minus B. Is everyone down with those two? Do you see this is close to one of those denominators? It is the opposite of one of those denominators. Which one is it the opposite of, the red one or the green one? Since this is a positive b, you're going to look for the one with the negative b, right? Isn't this a negative 5? You're going to look for the one with the positive 5. You see how these two are opposites. So they will reduce. The thing is, what will be left over is you had to factor out a negative 1, so I'm just going to put a negative 1 on top of one of those guys. Is everyone with me on the negative 1 got factored out because they are opposites? So now you're left with negative AB. You see that? You took the negative 1 times the AB over 5 plus B. Can the B's... Bottom guy, he's a binomial, correct? Top guy is a monomial. You don't get to do that cancel trick unless it's in all 3 parts. Is the B in all 3 parts? No, because we would have factored it out in the bottom as a GCF in the first place if it was, right? So this is it. Yep. Next one. Go for it. Pause the video. Top can factor, bottom can factor. Just factor each one of them, and then we'll stop. The top guy is the difference of squares. Is everyone cool with that? This is a perfect square. This is a perfect square. They're not in the order that you like them to be in, though. Don't change their order. Don't change their order. Don't change their order. Conjugates. 6 minus x, 6 plus x. You see how the 36 came first? Its square root is 6. Bring that first. Okay? Same thing with the x came last. Keep the x last. Don't switch their order around. Bottom guy. That's a trinomial. Correct? Let's go through it right here. Is it a perfect square trinomial? Yes or no? The first guy's 2x squared. 2x squared is not a perfect square. So we got to come down to here. Is the a value 1? No, it is not. Is the a value not 1? Of course it is. So it's time to do the frowny face factor. I will let you frowny face factor the bottom guy. Go off to the side is what I'd recommend. Well, I guess you can work straight down. If you're working to the side this way, work straight down, and let's factor that guy. Yay for factoring. So here's our numbers. First guy leads off. Which one do you want to put next? It doesn't matter which one would be to our advantage. The negative 12x plus 1x minus the last guy, or whatever the last guy is. Group. Take out a GIF. 2x, x minus 6. This is an x minus 6, so you got to pull a GCF out, which is 1. Regroup 2x plus 1 times x minus 6. That goes down here. 2x plus 1 times x minus 6. Nothing perfectly cancels. Do you have a set of opposite binomials, though? So finish this problem. Which ones are opposites? When you're canceling opposites, a negative 1 has to pop out of one of them. Wouldn't that be these with a negative 1? Did you hear it pop out? Negative 1 pops right out of there. Yeah? So you're left with negative 6 plus x over 2x plus 1. Don't need to distribute the negative through. I mean, you could if you wanted to. Don't do it. You know, just leave it that way. It's all good in the neighborhood. One more of those. Is it a multiplication problem or division problem? That's the question. Division. So that means the second guy's got to get reciprocated. Go ahead and give it a shot. In our first dude, he's a difference of squares. The second guy, not a perfect square trinomial, but easily factorable. Got to reciprocate because we're dividing by a fraction. GCF of 5 pulls out of this brother, which goes in our numerator. GCF of 3 pulls out of that one. Cancel time. A minus 6, A minus 6. Gone. A minus 2. Don't have any A minus 2s. I got an A plus 2. Do I have an A plus 2 upstairs somewhere? In the wrong order, but isn't the 2 positive and the A's positive? Aren't these both A plus 2s? So boom, boom. These guys right here, close but no cigar. Are they opposites of each other? This is a negative 2, that's a positive 2. This is a positive A, that's a negative A, right? So those are opposites. Means they can cancel, but of course, a negative 1 has to pop out. Did you hear it? Okay. And what's left? Negative 5 thirds. Yay! All variables going. Cool. And then finally, the last part just talks about what a complex fraction is. It's kind of good to learn the lingo. It's a fraction inside of a fraction. You've got a larger fraction bar. You've got a fraction on top of a fraction. Can't have it. We do the same thing we've just been doing. You keep the first dude the same, and you multiply by the reciprocal of the bottom guy. So that's how we'll do these next ones. You see how we have a complex fraction, correct? First guy I'm going to keep the same, A plus B over 4. And if you could factor at all, maybe I'd factor him before I'd rewrite him, you know. But that one doesn't factor. Then instead of dividing by this guy, multiply by the reciprocal, which is 4 over A squared plus B squared. Is everyone down with that? Right? You with me so far? Now let's talk. Before I try to multiply across or anything like that, I don't want to really do that because binomial, right? If they were like all monomials, you could multiply across. We got some binomials, some monomials, etc. First thing I want to show you is 4 upstairs, 4 downstairs. Don't those go away? You with me on that? 4 up, 4 down, they cancel. A plus B right here, that is a binomial. Is there a GCF that can come out of that at all? The only question now is, can that factor? You and Pal discuss. Can that factor? Is A squared plus B squared a difference of squares? Yes or no? Why not? Because it's a sum, not a difference. It's A squared plus B squared. You with me? Is it a difference of cubes? No, they're squared, not cubed. Is it a sum of cubes? No, they're squared, not cubed. That means that that can't factor. So you're left with A plus B over A squared plus B squared. The question someone asked was, can we play where are there more with those? That's a great question. Because they're like, there's some A's upstairs, some A squareds downstairs. It's a binomial over a binomial, though. It doesn't work that way. The only time you can play where are there more is if it's monomials over monomials. So that is our answer right there. A plus B over A squared plus B squared. Last one, my friends. Rewrite. First guy stays the same. Second guy gets reciprocated, and we're changing it to a multiplication problem. If you want to factor as you rewrite, that's great. If not, whatever you feel comfortable with. Give it a shot, video peeps. Here's what it is before you get it all factored down, or like once you get it all factored down, but before you get it reduced. Y minus x upstairs. I'm going to look for a y minus x downstairs. Do I have any? Nope. Maybe I have some opposites, though, right? Since I have a positive y, I'm going to look for a negative y. Here's a possibility, right? I have a negative x. Is this a positive x? So these are opposites. They will cancel and pop out a negative 1 in that situation. So can anything else reduce? That's the question. Tell me what kind of polynomial this brother is right here. Mono, bi, tri, what is he? Monomial. I'm going to look for other monomials. Isn't that a monomial? Right? Can anything cancel out in that situation? What if I wrote this as x times x instead of x squared? Can anything reduce out of these two? Can't you cancel out an x? Right? Monomials over monomials, you can do the where are there more situation. So, this is gone. You're left with negative x over 4 times the quantity of x plus y. Notice how I put the 4 in front of that. You always want to put your coefficients first. With me? Not with me? It takes practice, right? We're pretty decent factorers. It's the old seeing the opposites, looking at the monomials that can cancel the really, really, really simple stuff. So if you need help, come see me and I will help you.